At the Atomic Energy Radiochemical Center at Amersham, there arrives week by week a very ordinary-looking lorry. But its cargo is a strange one. It has come straight from the atomic piles at Harwell and Windscale. And it's a dangerous cargo. Within that heavy lead container lies power. Silent, invisible, deadly, wonderful power. Certain materials that we use every day, salt, copper, iron, and even gold, have been close to the source of endless energy in the atomic pile. And a part of them has changed. Now they constantly send out invisible rays. They are radioactive. They have the power to kill, to cure, to search. Perhaps the most wonderful of these radioactive materials is carbon-14. For this can be made up as part of almost any other material. Oil, sugar, alcohol, food, and all the time the telltale rays are sending out their signal. By following these rays, the very workings of nature can be traced. But at first, the radiating materials must be separated from the rest, behind 4-inch lead bricks or thick perspex. For all of these rays are invisible, and some deadly to man. This thin tube contains a very small amount of carbon-14, almost the same carbon that's in the coke that we burn at home, but with a difference. This is radioactive. The first job is to open the tube, and this is not as simple as it sounds, for everything in this laboratory is done by remote control. Now the powder is bored out of the container, seen for the first time since it entered the heart of the atomic pile. A keen eye and a steady hand is essential here, for every particle is valuable. The Geiger counter stands on guard to give warning if the radiation reaches the danger level, for this is an unseen enemy. Shielded against the invisible rays by long rubber gloves, the technician's next job is to place the seemingly inoffensive powder into an electric furnace. Here it will be heated up until the carbon burns to a gas. There's an old joke about a magician who says, "My next trick is impossible." The scientists who work in this laboratory might well say, "The next thing I make will be invisible." For that's pretty well the case in the early stages. It is here, amongst this weird collection of tubes and retorts, that radioisotopes are produced, and the raw materials, as they might be called, are in the form of a gas or vapor. To make this almost invisible product move or collect into one place, liquid nitrogen, many times colder than ice, is used. And sometimes only the Geiger counter can find the whereabouts of the ray-producing material. The final products of this strange process are almost exactly the same as the articles that we use every day. They can be sugar, motor oil, alcohol, even detergents. But there's one great difference. They continuously send out the telltale rays. Wherever they go, whatever form they take. And by following and tracing these rays, scientists can study movement and changes which have so far been invisible. What happens as a plant grows? Most people have heard of the deadly nightshade. How does this pretty flower, the belladonna, earn its sinister name? How does it produce its deadly poison, atropine? By feeding the plant with food containing the tracer, it's possible to follow the gradual stages in the life of the belladonna by means of the Geiger counter. The deadly nightshade is now doubly deadly. It is radioactive as well as poisonous. But by means of such research, the secrets of nature are gradually unfolded. The unseen power of the atom is working for the good of mankind. Although the atom is invisible to the eye, its energy is almost limitless. Great ocean-going liners and tankers, which will be powered by mere handfuls of atomic fuel, are now being designed. The National Physical Laboratory, set near the River Thames at Teddington, plays a great part in testing huge vessels of this kind. In its ship division, where the Dam Buster's famous bouncing bomb was tested during the war, investigation into the latest hull design is carried out by using scale models. Strangely enough, these model ships are generally made in wax. The first step in the construction of these models is to build a core of lath and cloth, and this is then hung in a mold formed of china clay. Hot molten wax is poured into the mold. And when this is cooled, it has taken the rough shape of the hull. The next job is to cut the wax to the lines of the new ship. As this machine follows a scale plan of the vessel, the high-speed knives skim the hull into shape. Then, after being hand-scraped and polished, the model hull is an exact miniature of the real thing. Now comes the time for launching, but on this occasion, the champagne and brass band are missing. Loaded with weights to represent cargo, the test piece is ready for its first trial run. By the time these model ships are finished, they're about 16 to 18 feet long and weigh about a ton. When you're next at sea, remember that the lightship that guides your way first started life as a test model, in this case a wooden one, and that some of those graceful yachts that you wish you could afford were first tested at Teddington. Now comes the time for the test, and this is carried out in a huge tank, 580 feet long and 12 feet deep. The models are towed through the water by a huge traveling carriage, on which technicians operate equipment which records every movement of the vessel and the forces it encounters. The first test for this wooden model, a patrol boat, is in calm water, and for this it is towed under the carriage. Well, she seems to behave all right in calm water, but what will happen when she meets some really rough weather? The backroom boys return to the start and get ready to find out. At the end of the tank, the huge wave-making machine slowly begins to move. This wave maker can produce almost any kind of sea you wish, including storms and gales. Now the rough water test begins. Inside the model are instruments which tell how the real ship will stand up to the buffeting of the waves. The speed is gradually increased. In the case of this patrol boat, the test shows that the vessel is taking too much water over the bows. When the faults found in the scale model by the tank test have been put right, those who sail on the full-size ship can be sure of the seaworthiness of their vessel. Her Majesty's Royal Yacht Britannia steams quietly through the night, but this time she's not likely to get very far. For she's a model under test in the open jet wind tunnel of the National Physical Laboratory. The aim of this experiment was to design the funnel of the Royal Yacht so that smoke could not blow down onto the deck or discolor the funnel. The new Orient liner Oriana, not yet complete, undergoes the same type of test, and the smoke is shown up clearly by the special lighting. Would smoke from the Bankside power station in London blacken and pollute St. Paul's Cathedral? Experiments showed that this would be unlikely. Research is made into almost every subject at the National Physical Laboratory. In one of the low-speed wind tunnels of the Aerodynamic Division, a working model of a twin-rotored helicopter is being put through its paces. In a few years' time, the helicopter may be the flying bus of the age. Let's hope that the fares don't rise at the same time. You know, for some reason that I've never discovered, these boffins like to test their particular problems upside down. Not that it matters, for they always get results, but it is a little disturbing at first. In this case, they're carefully studying the tips of the rotor blades. It seems an aeroplane behaves in a different manner when it's turning at great speed to that when it is flying straight and level. To find out just how and why this happens, the National Physical Laboratory built a giant whirling arm at Teddington, on which they swing models round and round at speeds up to 70 miles an hour. There are instruments inside the model, and these send signals which record how it's behaving. Facts found from this type of experiment form the basis for future aircraft design. Adding up and analyzing all the problems and answers of research work would take many men, many days, even months. But Deuce takes all this in his stride in a few moments. Deuce is a high-speed calculator, an electronic brain, and he's a sort of cousin to Ernie of Premium Bond fame. But Deuce is more serious-minded. He's the one that works out your tax tables on budget night. All Deuce asks is that you feed punch cards into him at one end. He'll then make a lot of weird noises. Who wouldn't with 1,000 valves for an inside? And then he'll give you the answer in a few moments. But the scientists have also given Deuce a memory. Plus, of course, some down-to-earth things to remember. They've even taught the machine to hum a tune. And a very well-known tune it is. With the help of machines, the world draws nearer to the great mystery of the universe. Britain's new radio telescope looms 180 feet above the countryside and is the largest and latest of its kind in the world. This is a strange telescope indeed, for it has no lenses or mirrors. Instead, it has transmitters which send out pulses that return to the Earth as radio echoes. Echoes from the moon have been received at the Jodrell Bank Experimental Station, and signals from outer space are now being investigated. Signals from star systems so far away that the light from them would take 1,000 million years to reach our planet. This telescope probes into the very depths of outer space. Man has already mastered the air. Now the last great challenge awaits him, the conquest of space. And man himself is perhaps the only stumbling block. Machines can be built that will venture into space itself, but how much stress and strain can the human body stand? At the Royal Air Force Institute of Aviation Medicine, Farnborough, doctors strive to find out all that happens to a man as he travels at great speed and height. In the climatological laboratory, all the temperature conditions which the pilot will meet on the borders of space can be created at will. Heat, scorching heat, wind, ice. And men of the RAF spend week after week shut off from the rest of the world, testing apparatus which will assist others to live under such conditions. The delicate, almost lace-like design of this suit contains devices which keep the pilot's body at an even temperature, even while those around him are pouring with sweat. In the decompression chamber, doctors, Britain's flying doctors, check with X-rays on the reaction of the human body to great heights. Can a man live if an enemy missile splits the pressurized cockpit and hurls him into the airless void? A test is made on a volunteer. Suddenly, all the air he breathes will be withdrawn. Stand by. 6, 5, 4, 3, 2, 1. Now. The air blasts from the chamber and the subject fights for breath. His face blown out by the air rushing from his lungs. His ears sing. But with the aid of his equipment, he can live where no man can live without these aids. Aviation and space doctors have the most difficult problem of all to overcome, the effect of G upon a human body. G, meaning gravity force, is something that happens to a man when traveling above the Earth at thousands of miles an hour. He has to change the direction of his machine. This huge revolving arm, the human centrifuge, can give the pilot the horrible effects of this strange force whilst he's still upon the ground. Dressed in his anti-G suit and strapped into the machine, he will soon feel the terrible thrust that a rocket or spaceship gives as it starts its journey into the dark regions of the universe. This doctor will take 5G, 5 times the force of gravity, and then his body, his brain, his blood will to him weigh 5 times as much. His G-suit will help him, though, by squeezing his body and pushing the blood back to the brain. Otherwise, he would black out, or even die.
Hello, subject. Can you hear me all right?
I can hear you well.
During the run-up, I want you to tell me if you have any visual symptoms. I will tell you when we reach peak G. Then I want you to pull the ejector line. All right?
Okay.
Hello, controller.
Hello, observer.
Could we have a 5G run, please? 1 G a second rise, and 15 seconds on top.
5G at the 1 G per second rate, 15 seconds at peak G. I am ready to go, observer.
Are you ready, subject?
Ready.
Ready, controller.
Stand by. Start.
force of gravity begins to take effect. The blood begins to drain from his eyes. He's almost losing consciousness.
Beginning to clear out! Is your G-suit inflated all right? G-suit's inflated!
He must reach
Eject.
the ejection seat firing line.
Hello, subject. Are you all right?
Yes, I'm all right. Quite a bit of toppling at the end of that run. I felt as if I was falling flat on my face.
Was the grey out a bad one?
No, it wasn't a bad one.
Okay, I'll call the other boys and let you out.
But there is yet another instrument of space research. The high-speed rocket track. In this test, doctors, all volunteers, are forced along the track by rockets. And within half a second, they stop. A crash impact. The rockets are placed into position. Man must withstand the acceleration required to reach a speed of 23,000 feet per second if he is to escape into space. The effect of this test will be exactly the same as if he were crashing into a concrete wall in a car traveling at 80 miles per hour. This is the first time that this Royal Air Force rocket track has been seen by the public. This Royal Air Force flying doctor has just received 16 times the force of gravity. For a fraction of a second, he has experienced something that is beyond our comprehension. If the world is to continue its search into the unknown, men must be prepared to face that unknown. It's good to know that there are such men in Britain, men who will keep this country in the lead of the worldwide search for knowledge. The planets and the stars await us. One by one, man is revealing the hidden secrets of the universe. How long before he pierces the last barrier, the barrier to the vast frontier of space?